Hello, welcome to another week in astronomy. Not necessarily the biggest news, but what interested me the most. Firstly, using LiDAR to track ocean animals. Recently a paper published in Nature on November 27th has used this method to track the vertical migration of many marine animals to the surface to eat plankton at night, and they then drop back down during the day. They use the cloud aerosol LiDAR and infrared pathfinder satellite observations, which has the acronym Calypso, and a sensor on that referred to as MacLeod. This is a collaboration between the French National Astronomy Groups and NASA, MacLeod being a satellite cloud aerosol LiDAR. So first up, what then is a LiDAR? Well, it's a combination of the words light and radar. Basically covers what radar does, but using light from a laser. You see, if you emit light from a laser, it has a very specific frequency. It scatters off some objects and returns to the laser. So there's a couple of interesting things to note about this. Firstly, you can choose the frequency of light from your laser to reduce the scattering from some things. So for example, a lot of frequencies of green are used to map the sea floor, as they avoid being heavily scattered quickly by water molecules. They can penetrate to some vertical distance below the surface of the sea and map the sea floor. The other interesting thing is that you can use the time delay between your laser pulse sent and when it's received to calculate the distance between you and the target. You can see how this could work then. Look, in this experiment you look for light backscattered by plankton and small fish and then map the vertical distribution you get. That's what this paper does, but rather than using a ship-based LiDAR, they use a satellite-based system, MacLeod, which traces a much larger area. They have a laser footprint with 100 metres diameter working to a depth of 22 metres to make this map. Unfortunately I'm not a biologizer, so I can't really discuss this much, but it does look cool. And it's an example of the coverage benefit to using satellites to image the Earth, which is an area where astronomy really benefits humanity. If you want a 100 metre diameter footprint at the Earth's surface from some small box like a LiDAR, it's much more comfortable to have the thing high up, and satellite is a really good plan for this. I'll link to the Nature article about this in the description. If you want to read it, yeah, it's behind a paywall, there's ways of getting past that. The other thing I want to do is have a rant about another bloody black hole that shouldn't exist. You see, some researchers wrote this really interesting paper called A Wide Star Black Hole Binary System from Radial Velocity Measurements. It's a very interesting paper. They used these radial velocity measurements for a galactic star called LB1, which has a companion. They narrow down the mass and the distance of the companion to the point where they say it's a black hole of about 70 solar masses. They give 68 with errors of plus 11, minus 13. So, should it exist? Well, as the paper says, the gravitational wave experiments have detected similarly massive black holes, but forming such massive ones in a high metallicity environment would be extremely challenging to current stellar evolution theories. Basically, as the authors point out in various news reports on the subject, stars massive enough to produce this size of black hole in this high metallicity environment, with the star having a composition that reflects that environment, they're expected to shed most of their mass at the end of their life due to having large stellar winds. And if they do, why would they leave behind such a huge remnant they're supposed to shed their mass? So a quote from Dr. Liu Jifeng appears in a lot of reports on this. He's the lead on the paper and has said, black holes of such mass should not even exist in our Milky Way galaxy, according to most of the current models of stellar evolution. But a few things are obvious to pick out. Firstly, he says, according to most models. That's a hedging of bets that disappears in a lot of articles about this. It also leaves open the idea that this black hole may have formed as part of a multi-star system. It's discussed in the paper as the authors talk about possible ways that this black hole could form, and throw out the idea of a 3-star system with the black hole forming from 2 of those stars. It's more complicated than this, but you can get the gist of the idea from considering the stellar wind statement. Could you fabricate a situation where less material is ejected? Another option they put out is this idea of an observed star orbiting a very close together pair of less massive black holes. I suppose it's not that important. I can see why impossible black hole is what gets into the title. It's more fun, and I'm not too mad since a lot of the articles about this that I've seen did go on and at least quote Yufeng on most models, including his description in their article. But even with that, it does grind with me slightly, this overbearing urge to make science articles about a grand overthrowing of current models, even if the story is slightly less than that. Because this is really interesting research, and while the paper discusses possible reasons, a possible reason isn't the same as a full explanation. The question of why there's a stellar black hole in the solar system this size is still open, but we don't know why it's there is not the same as it should be impossible. And one last tangential rant from me. Our theories of star formation are designed to be fairly general. They get the gist of how star forming systems work based on what we see commonly in the universe. So there'll be a lot of things that these models don't predict, not because there's something terribly wrong with the model, but because it's an edge case. The model works, but some systems in some unusual environments produce highly unlikely things, and in a Milky Way estimated to contain hundreds of billions of stars, weird stuff turns up. And it might seem to be in conflict with what we know, not because we've got something terribly wrong and a found impossibility, but because the system is so out there and weird that nobody would have thought to consider those stars in that system. But hundreds of billions of stars, it can turn up, and when it does we don't have an explanation to hand. But anyway, enough complaining. I'll link to their article as well as a few news stories about that as well. Goodbye.